Hello guys, welcome back to our channel The Data Odyssey and to the first series related to data engineering on this channel, which is related to Apache Iceberg. Alright, the world's most trending universal open table format. Right? So, in the last video, we talked about the asset properties, the most important properties behind reliable data transaction. Okay, and in this video, we'll start with the journey of data management. Now, this video is your answer to why we had studied about asset properties in our last video. So, if you people have not seen the last video, I would recommend to you to go through the last video because it's a very small video which is of 8 minutes, I think. All right. So, rather than wasting the time, let us start with the journey of history or the history of data management. Okay. Okay. So, yeah, so in and around 1970s, the data management system, the first data management system that came into existence in the world was the relational database, and it was a very important revolution in the world of data management. All right. Now, what is a relational database basically? I would use a technical term over here, okay, but moving forward over the next slide, where we will talk about the architecture of these data management systems. I'll try to explain to you in layman terms. All right. So, yeah. So, what is a relational database basically? This relational database is an OLTP system. Okay. Now, what does an OLTP system mean? The full form of OLTP is online transactional processing. Okay. Online transactional processing. Now, itself from the word transactional over here, you can understand this that this system is somehow related to the processing of transactions. Okay. Now, what does processing of transactions mean? Think basically like in a business, in a ticket booking system, when new tickets are being booked every day by an individual user or multiple users, then transactions or record of that individual booking is being made into a particular system. Correct? So that is a transaction. Basically, that individual record being put into that system is the transaction. All right. Now, this relational database is utilized to record those transactions. Okay. So, when you are recording those transactions, there are two things that will happen, right? So, either you are writing to this system, correct, or you are reading from the system, right? That's it. That are the two basic operations that are occurring on this system. Okay, and that's why it is an online transactional processing system, correct? Now, suppose, like, not suppose, what I want to tell you, like, as data evolve, the volume of data increased over time. What happened? That people understood the importance of data. All right. Like, they understood that if we perform certain level of analytics on a particular set of data, rather bigger set of data, we would get some insights about our business. Okay. And those insights triggered the minds of the scientists or the engineer that we need to devise a new kind of system which is more focused on analytics rather than the transactional aspect. Okay. Now, if you have a doubt in your mind that whether this system can be utilized for analytics, okay, so, yeah, I wouldn't say no at all. Like, yes, this system can be utilized for analytics, but the problem or the issue over here was like it would kind of create a pressure on the system, and the entire process of recording transaction on also the analytics being performed would slow down. And why would it slow down? Because single system was being utilized for both the purposes, and it would create a kind of pressure on the system, just thinking that way logically, right? So that's why the scientist or the engineer thought of developing a new kind of system called as the OLAP. OLAP, okay. Now, what is the full form of OLAP? OLAP basically means online analytical processing. Okay. So they devised a new kind of system which would be more focused upon analytics rather than recording of transactions. Now, the entire series of innovation that came in the world of data management systems after this OLTP was related to OLAP only. Okay, so it was more focused on OLAP rather than OLTP. All right. Now, the first innovation in the OLAP series was the data warehouse, okay, which came in around 1980s, but then it evolved till 2010. Okay, it evolved in the 2010, and in and around 2010 came the data lake, and then the data lake house. All right, which was in 2020s, and this is the most recent development in the world of data management. All right, now there might be certain issues in data warehouse because of which we evolved to data lake, and then we evolved to the data lake house. So flaws in one system is the cause of evolution in another or the newer system or the better system, correct? Now, what is a data warehouse basically? Now, data warehouse is nothing. I have given or like put a symbol of a house over here, right? Now, what does a house mean? A house means a place where the entire family stays together, correct? So, data warehouse is nothing. It's the family of data staying together. So, multiple sets of data are being brought together into one place in a data warehouse. That's what entire OLAP is also focused upon. Okay, that was the basic concept behind the OLAP systems, or you can say the data warehouse. Okay, because data warehouse were the first systems which are developed in the world of OLAP. Correct. Now, this was the thing. Now, what data warehouse is focused upon was it collected mostly the structured data, or I wouldn't say mostly. It was more focused upon collection of structured data. Okay, but as systems evolved over time and people understood that we would also require to store unstructured and semi-structured data, because for example, what do you mean by the unstructured data? Like the images, okay, the videos, all of these belong to the unstructured community of data. Okay, and then we also have the semi-structured data. Okay, now, what does semi-structured data mean? Basically, you can consider those logs that are generated. Okay, many of them are in JSON format, correct? So this JSON, this XML, all of these are semi-structured data. Okay. Now, what happened? This data warehouse, since it was first of the developments in the world of OLAP, they didn't capture the semi-structured and unstructured data. It only captured the structured data. Okay, that was a major flaw in the data warehousing world, and people over time when understood the importance of this unstructured and semi-structured data. For example, this unstructured data, these images, these videos could be utilized in the world of deep learning. Okay, the models could be trained and many newer form of analytics could be performed upon these or are performed upon these in today's world, correct? So right now what happened, that system engineers understood that we require a newer system of data management system, correct? And then data lake evolved. Okay, and then the data lakes evolved. Now, data lake evolved to hold larger sets of data, correct? And there was another issue with the data warehouse even. What happened, that in data warehouse, like we will also understand this point in the upcoming slide where we talk about the architecture, that the major concern, another major concern with data warehouse was everything was proprietary. Okay, proprietary. Now, or you can say vendor locked in. So all the components that we have in an OLAP workload are are fixed by the vendor. We cannot change them. But Data Lake introduced or told us that nobody, you can decide your own components, what you want to use, and that's why the Data Lake evolved. Okay. Now, since this dealt with the structured data, it also ensured asset reliability. Okay, this data warehouses ensured asset reliability. That was a very important factor. But what happened with the data lakes was it couldn't ensure these asset properties because people couldn't understand or slowly started understanding that this data lake had turned into a data swamp. Now, what is a data swamp? Ugly storage of data, you can say. Okay, so very poor form of bringing data into one place. Okay, because multiple copies of the same data could be stored in one place, and we might not have any kind of track record of how many multiple copies of that data has been stored. Okay, so that's the point, that the data lake became very ugly or dirty place to store data, as all data were brought in and they're being dumped like a garbage. Okay, they were being dumped into one place. So what happened? Scientists understood that okay, although data lake resolved that bigger issue of proprietary vendor locked in components or the structured data, it couldn't ensure the most important property behind data reliability, which is the asset property. All right, and that's when the data lakehouse came in. All right, now what did data lakehouse ensure? Like lakehouse not only ensured the asset properties, it also ensured that all kinds of data could be stored. So it ensured the structured data. Okay, it ensured the unstructured data, and it also ensured that semi-structured data could be stored. And along with that, it also ensured that no vendor lock-in. So everything is in your hand, correct? So that you are ensuring all these things and everything is your hand. Now, where does this data lakehouse term come from? So it comes from the term data warehouse plus data lake. So data, then this warehouse and this data lake. Okay, since they replaced the word where and just told it data lakehouse. Okay, data lakehouse. So that's the entire journey of data management. So we understood that how systems evolved over time to store bigger volumes of data. Okay. Also, another issue was there. Okay, related to this data warehouse. What happened that all the things were coupled, all the components were coupled with one another. Okay, and this decoupling occurred when data lake came into existence. So that was a bigger relief. So coupled components. Now we'll see it in the next video. What do I mean by these coupled components? Okay, so in these two systems, like in the data lake house, the decoupled components. Now, about what kinds of coupling or decoupling of components I'm talking about, we'll study in the next slide. Okay, so this is the entire journey of data management basically. So, in and around 1970s, the relational database came, and from in 1980s, the data warehouse came into existence, and around 2010, the data lake came into existence, and 2020s, the data lake house came into existence. So, this is the bigger picture of the history of data management. Okay.